Hey class, let's go ahead and take notes for 6-2. So this is what I'm going to be looking at whenever I'm taking my notes in my journal. So if you wanted to print this, that's fine. If you don't, that's fine too. So let me close this and make this big. Well, let's see. Okay. So we have 6.2 real applications of normal distribution. So sometimes we want to convert values to standard scores, the z-scores, remember? You're going to do whatever x value you have minus mu, which is our mean, over standard deviation. So remember, this is your mean, and this is your standard deviation. And x is the value that you're testing. Okay, so we have been working with standard normal. And this is where you have 0 is your mu and 1 is your standard deviation. This is called normal distribution or standard normal. Whenever you have a mu of 0 and a standard deviation of 1. And we've been going to find x, what x is, and then finding our z, our area. Okay, so what we're going to do, because not everything is standard normal, we are going to have to convert from non-standard normal distributions. So non-standard would be where you have your mu, and we are going to change, well, this was x, and now it's going to be z. So you have this, and you're going to get that. Use that formula, z equals x minus mu over sigma, to get this. Okay, so ways to do this. So this is our how-to. So first thing you're going to do is draw your normal curve. Label your mean and x value. Then shade the probability. So you're going to do this, do that, identify your mean, whatever that mean is, and then wherever your x is. So sometimes x is over here, sometimes x is here. You just got to know where x is, and then shade the probability. Step 2 will be to use that formula, z equals x minus mu over sigma. And to convert from x to z. 3, you're going to use the table A2 or your calculator to find the area. And remember, the shaded region is your probability. Remember, because they are directly related. Okay, so let's look at some examples. So here's an example. The safe load for a water taxi was found to be 3,500 pounds. The mean is assumed to be 140 pounds. Let's assume a worst case scenario of which all passengers are adult male. Based on this information, assume the weights of men are normally distributed. distributed with a mean of 172, standard deviation of 29. If one man is randomly selected, find the probability that he weighs less than 174. Okay, so using this, I'm going to write some things down. So we have a mean of 172, and our standard deviation is 29. And it's saying, what is the probability that X is less than 174? So let's look at our curve. We're going to label our mu 172. 174 would be right here, 174. And we want less than. So now we're going to shade to the left. And we want to find the area to the left. So our instructions say to convert that X to a Z. So remember, Z equals X minus mu over theta. Okay, so X is the 174, because we want to know what this is. This is X, but we want it to be as a Z score. Minus 172 over 29 equals 2 over 29. And we need to write that as a decimal. 2 over 29, 0.0. We can put 6, 8, 9, or let's go ahead and put that 6. Well, it'll actually be 6, 9. Okay, so then the next step is to use our table, the A2. And this is a positive Z-score. So here is my table. I'm going to look for what's the closest to this on our table. It would actually be, so I'm going to look at the table, and I'm going to look at 0.07 and see what that equals. So 0.07 is 0.5279. 0.5279 is your probability. So probability that X is less than 174 equals that. Okay, the other way with the calculator, we are going to, so this is with the table, this is the calculator. So we are going to do second VARS, normal CDF, and the lower is basically infinity. The upper is 174. Our mu is 172. Theta is 29. And look how close that is. We didn't even have to use the Z in order to find it. So using the calculator, probability that X is less than 174 is 0.5275. Oh, I forgot the 2 there, sorry. All right, so let's think about what the steps were for the calculator. So second VARS, and then it's number 2, which is normal CDF. Okay. And then our lower was that -1 E99. It's just a really small number. Upper is going to be 174. Lower, mu 172. And then 29. And then push enter. So that's if you have one of these. Okay. So that was the first example. So let's see, next example. Actually, we're going to summarize, write a little summary here. Using the table, to the left of 0.07, using the table, we find the area to the left, there we go, sorry, of 0.07 is, we found it, 0.5279. So the probability is 52.8%. So the probability is also 52.8% of men weigh less than 174 pounds. And so the opposite of that would be weighing above that. So you'd have to do 1 minus 52.8. No, 1 minus 52.8. There we go. One minus 0.528. There we go. 47.2% and 47.2% way greater than 74. 174. So that's just a little summary. Basically, using the table, that is what we get. We can convert that to a percent and then summarize, okay, 52.8 way less than 174. So then to the other side, which would be up here, greater than 174 is 47.2. Okay, so let's do another one. Go ahead and read that, and we're going to write down the important information. Okay, so one thing would be a mean of 100, standard deviation of 15, and it says we want probability that X is between 85 and 125. So we draw. So we do 100 is our mu. So 85 is right here. 125 is right here. We're finding the area between those two. The IQ scores between 85 and 125. So it's that area right there. Okay, so we can use our calculator, or we can do it by hand. With finding our Z, we're going to do, we got to find both of them. We got to find this Z score, and we got to find this Z score. So we'll do 85 minus 100 over 15. Gets us negative 15 over 15, which is negative 1. So this is negative 1. And then this one, 125 minus 100 over 15. 25 over 15. 1.67 if we round. Okay, so we can use our table to find that. So we have a negative 1 first. So for negative 1, let's see, 0.1587. 0.1587. And then I got to do my positive. Let's see, what is that? 1.67. 1.67. 0.9525. 0.9525. So this is telling me that the area right here is 0.9525. And then this is telling me that right here is 0.1587. So in order to find out what's just between them, we subtract those. This from this. So let's see, 0.9525 minus 0.1587, 0.7938. Check. Okay, yes, that's what I got. Okay, and then if we were to do the calculator, we can do that as well. So I do second VARS, normal CDF. This time my lower is going to be 85. My upper is going to be 125. U is 100. Standard deviation is 15. Look at that. Came out the same. 0.7936 if we round. Okay, so pretty similar. So you've just got to decide which one that you want to do. Knowing how to get the z-score, that may be a question, and then actually finding the area. So the probability of an IQ score between 85 and 125 is about 79.4%. Not too bad. Okay, let's look at the next one. Women have heights that are normally distributed. Mean of, so I'm going to write, I'm just going to do it on the next page. It's just easier. Example 3, we have a mean of 63.8, standard deviation of 2.6. What is the percent who are at least? So at least means it's going to be greater than or equal to 70 inches. So now we're looking at the area to the right. So we know that this is 63.8, and we're looking at 70. So we're looking at this side. So with the table, we can find this, the left side, and then subtract it from 1. So we need to convert this 70 to a z. So z equals 70 minus 63.8 divided by 2.6. 70 minus 63.8, 6.2 over 2.6. 2.38. All right, that'll be closest. Okay, so then we can use the table to find the probability. So this is a positive, so 2.38, 0.9913, 0.9913. That's the area to the left. This is our left area. We want to go to the right, so we're going to do 1 minus 0.9913. 1 minus 0.9913. 0.0087. So that's less than 1%. So in order to do the calculator on this, we would do the same thing, second VARS, normal CDF. Our lower is going to be 70. Our upper is going to be just a huge number. So I'm just going to put a really big number. 63.8 and then 2.6. 0.854, pretty close. 0.085, pretty close. All right, so y'all are getting the hang of that, hopefully. All right, so then let's see what else we need to do. So let's say we know the area, but we don't know the other values. This was one more example. I'm not going to do it with y'all though, but it's talking about the area between. Okay, so let's look at the next part, how to find values from known areas or probabilities. So this is when we use the inverse. So how to find values from known areas or probabilities. So the first thing you want to do is you want to draw that normal curve. Draw a normal distribution. Enter the probability or percentage of area. Write area slash, remember area slash probability, because probability relates to area. And then identify what X value you're looking for. Two, you're going to look at table. Look at the body. So not the rows and columns, you're actually going to look at, this is the body of it, because these are the actual areas. So you'll be looking for these areas. And then three, you're going to use this formula to convert z-score to an X value. So it's X equals mu plus Z times standard deviation. And then 4 is look at your drawing and make sure that it makes sense with that new number. Okay, so we'll look at an example. So we had the previous example that we found the percentage. What weight separates 99.5 of men from the heaviest 0.5? Assume that the weights are normally distributed with a mean of 172 and standard deviation of 29. So what we want to do is draw the normal distribution. For example, we did example 3, we didn't write down 4, so we're on example 5. We are going to write down, we want to look at what weight separates. So we have our distribution. Write the area of probability. What separates the lightest, 99.5% of men, from the heaviest? So you're looking at the area here as 99.5 and this area as 0.5%. So we're wanting to know what that is. That's our X value, which what we'll look at is we are going to look at the body where the z-score is 0.995, or the area, sorry. And we're going to find so area equals that. What is the z-score? And then we're going to convert it back. So 0.995. So let's look here. 0.99555. So it actually tells us down here. So that is 2.575. You can see how it was right here, is right between those two. So we're going to look at this and it gives us that. So now I have the z-score. I did number 2, now I'm on 3. We're going to say X equals mu. We know what mu is. Let's see, where is that? Mu is 172 because that's something that they gave us. And then our standard deviation is 29. So I'm plugging it into this formula. So 172 plus whatever the z-score is times the 29. And that's going to get my x value, which will be the actual weight. So 172 plus 2.575 times 29. So x equals 246.675. So that is, if we look back at the question, it says, what weight separates the lightest? So these are the lightest. So 246.7, this is our weight, separates the lightest to the heaviest. So this value right here, if we put our 172 here, then it would be 246.7 pounds. So we found that. We can also do this with the inverse. I remember you showing me this. So the inverse norm, the area would be 0.995. Mu is 172. Yep, there it goes. So for the calculator, you will do second bars again, and then do inverse norm. And then you put your area, you do your mu, and you do your standard deviation. And then it'll pop up what that x value is. Okay, hopefully that will get you through these notes. If you have any questions, just send it to me and I can work it out and do a video for y'all. So it's not just, let me cancel that, okay. So it's not just me writing something, I'm gonna have to do a video in order to explain it. So hopefully this will help you get through 6.2 assignments. Let me know. See y'all later.